Thank you, Chrissy, and good afternoon, everyone. Welcome to this presentation on ChemX Materials. As the usual disclaimer, as Chrissy mentioned, ChemX Materials has a strategy of developing critical materials for the electrification and decarbonisation markets that are only just starting to develop. Our current portfolio consists of a new and unique technology to produce high purity alumina, and we've got two tenements on the EYRE Peninsula in South Australia which have manganese, where we're looking at producing a manganese sulphate material for battery cathodes and for Kaolin. Now this is the public unveiling of our corporate video which we released this morning.
Are forecast to grow into a near $1 trillion industry by 2028. High-purity alumina, more commonly known as HPA, is a key ingredient needed in the batteries that power every one of these vehicles. HPA is also needed in the rapidly growing semiconductor and LED markets, with global demand already projected to outstrip supply. And now, ChemX Materials has the technology to produce high-purity alumina right here in Australia. A unique and sustainable process that not only capitalises on that demand, but is expected to have a significantly lower carbon footprint than other competing technologies. Having just raised $8 million through an oversubscribed IPO, work will commence on the ChemX High-Pure HPA technology, the development of a pilot plant to produce HPA for offtake partners, and two exploration projects that include Kaolin and Manganese, all on the EYRE Peninsula in South Australia. The High-Pure technology is designed to be scalable and modular, allowing production to be localised close to the end buyer. This shortens the logistics chain and reduces the carbon cost of supply. The exploration projects on the EYRE Peninsula are targeting manganese for lithium battery cathodes and Kaolin, which has growing uses in decarbonising many industrial processes. Decarbonisation and sustainability are at the heart of our strategy, helping to reduce the carbon footprint of our industry and being at the forefront of new technologies that are yet to be developed. ChemX Materials is well on its way to providing the world with critical materials that build a cleaner, more sustainable future.
Sustainability is really at the heart of what we do. The markets we're selling into are very focused on sustainability, and we're at the lucky position of being at the start of our project development journey. We can build our sustainability framework around our project development, so we're not having to retrofit sustainability into something that we've already got. We listed on the ASX in January this year. Since then, we've been continuing work on the high-pure HPA technology. We've got a micro plant that is commissioning at the moment that has the capacity of about 5 kilos a day, and we've got Primero doing a pre-feasibility study on a pilot plant which will have the capacity of about a tonne a day. That feasibility study should be due by the end of this quarter. And on the EYRE Peninsula, as I mentioned, we've got two tenements there that have manganese and Kaolin deposits. Just on the HPA market, HPA is a critical part of every battery chemistry. It's coated on the separator. The growth in demand from the battery sector is very similar to the growth in EVs. So we're expecting very strong growth over the next 5 to 10 years. The other key market is for use in synthetic sapphire. Now, synthetic sapphire is used in LEDs, semiconductors, lasers, and a number of optical components. So if you've got an iPhone, the lens on the camera in the iPhone is synthetic sapphire. So it's quite widely used, and the demand is looking very strong from that market also. The technology that we've got to produce high purity alumina, what makes it different? It's scalable, so we can start off small and increase production as demand grows. We expect it to be lower capital operating cost. it's independent of mine production, and the key aspect of that is the time to market. We don't have to wait for approvals from the government and the development time frame for a mining operation. It uses an aluminous chemical which we can buy off the shelf. And it's also modular, so we can put production facilities close to the end buyers to reduce the carbon footprint of the logistics chain. The next steps for the high pure HPA technology, we're commissioning the micro plant at the moment. We've got the pre-feasibility on the pilot plant, which is due at the end of by the end of this quarter. That'll allow us to start the qualification process with buyers and start at the marketing with buyers in earnest. On the Eyre Peninsula, we've got 200% owned tenements. We're about 120 k's to the west of Whyalla, so from a logistics and a access point of view, in a very good position. The key point to note on this is that bottom point there on rare earths. The map there is actually from our neighbours, iTech Minerals. They've discovered ionic rare earths all around our tenement. Now, none of the kaolin on our tenement has been assayed for rare earths previously, but from our recently finished drill campaign, we will be getting, obviously, the assay being assayed for rare earths. The geology and in some cases the same deposits run across both iTech Minerals and our ground, so we're very confident that we'll actually have a rare earth ore body there at some, following up work. The recently completed drill program, you can see the quality of the kaolin there on that second one from the left. That's over 50 metres depth of very high quality white kaolin visually. We need to wait until the assays come back to confirm it, but it was white kaolin pretty much from top to bottom of the hole. The JAMIESON tank manganese project, it's been explored by a number of people. Western Mining was probably the most active explorer there through the 90s. The ore body itself is not amenable to a direct shipping project, but the mineralogy that we have is very amenable to processing. So the previous owners of the tenement produced a manganese, electrolytic manganese dioxide material. Upgrading that to a manganese sulphate is a similar process. So we've almost completed the first stage of test work on that, and the results to date have been very positive. And out of the recently completed drill program, we've got a couple of 100 kilograms of material going across to Perth to do the second stage of that test work, where the aim will be to produce a high purity manganese sulphate material. Why manganese? It's the poor cousin in the battery chemistry, but a few of the larger auto manufacturers, Volkswagen, Tesla amongst them, have come out over the last 12 months and said they're looking to increase the percentage of manganese in their battery chemistry. That's for a couple of reasons. It's cheaper than cobalt and nickel, but it also reduces the amount of cobalt you need in the battery, which reduces the ESG implications of buying cobalt out of Africa. So the next steps on that, we're waiting for the assay results to come back, and they should start to come back in the next couple of weeks. There'll be a follow-up exploration to further delineate it. The test work for the cathode material will be ongoing, and that's really the focus for it. So whilst we're looking at a vertically integrated project, assuming we get all the positive outcomes from the exploration and from the study work. And on the Kaolin project, again, we had the exploration program which we completed mid-March. We're waiting on the assays back from that, including on the rare earths. But the real focus on that deposit, whilst we have a positive outlook on the traditional kaolin markets, we're also looking at the uses for kaolin in decarbonising existing industrial processes. So one that we're working on at the moment is using kaolin in cement to replace the clinker in the cement manufacturing process. And that has a direct reduction in the CO2 component of the cement manufacturing process. The cement industry is about the 7th largest emitting industry of CO2 globally, so anything they can do to reduce their emissions, they're very keen to look at. So the next steps on that, again, waiting for the assays to come back. We've got the test work going on the cement replacement material as well. Once we get the assays back, we'll identify the markets that our material is suitable to, and then we can start marketing directly to those higher value markets. So over the next 12 months, we've got a very busy schedule. On the HPA, we've got the micro plant being commissioned at the moment. We've got the pre-feasibility study on the pilot plant. Assuming we get a positive outcome on that, we'll be moving straight into construction of the pilot plant in the 3rd quarter. And we've got the assays on the PENINSULA tenements. The manganese is really the key focus there, but also the rare earth potential is something that we're really keen to find out about. The board management, we've got a very experienced board in all the markets that we're operating in. I've been involved with high purity alumina for the last 5 years. The developer of the high purity technology, Nick Wellham, has been involved in a number of different technologies for high purity alumina. He's developed this and the high pure process and has taken the best parts out of a number of projects that he's worked on over the years, both in high purity alumina but also in other areas. So why invest in ChemX Materials? We've got a massive, massively growing market in front of us, and that's spread across a number of different industries to do with decarbonisation and the energy transition. The growth in those markets and also the innovation will lead to increased demand for both existing materials and also the development of new ones. And we've got the team and the strategy to be able to take advantage of the opportunities that the innovation that we're seeing will bring up. Apologies for the disrupted presentation. We've got a lot going on. It's a bit hard to put into 15 minutes, so if you've got any further questions or you'd like to talk about anything, please come down to our booth, number 38. Thank you very much.